Good morning to everyone. Myself SHAHIN BANAZEER, KGT Physics, KGBV CHAGALAMARRI. Today I am going to share a topic with you, that is ray optics. When we listen the word optics, we have to think about some optical instruments. Can anyone say a optical instrument we are using in our daily lives? Yeah, mirrors, spectacles, this all comes under the optics. Why we all use these things? Because they will give light, they will give brightness, a clear vision, isn't it? Ray optics, these are the main two words. How we can discuss about the ray optics is only by the light, If we are having light, then only we can able to see anything. In physics term, light is nothing but it is a agent which makes our sight to see the things. The light makes us to see the all objects surrounding us. For example, dear students, if I'll switch off the light, you are able to see anything? No. Why? Because for us the important thing is light. Here the ray optics entire, this topic revolves around the light. Here the light plays the major role in this concept. So today I am going to cover all these topics in the ray optics. Introduction of light. As just now I told that how important the light is for us. Next, characteristics of light. What are the properties of light and what are the behavior of light? Next, theories of light. Here different scientists proposes and they give some assumptions about the light. For every scientist, the light has shown different varieties of behavior. Next, reflection of light. This is the property of light, and we are gonna discuss about these topics here. Spherical mirrors. We know as every day in our lives we are familiar about the plane mirrors, isn't it? And in the spherical mirrors, we are going to discuss about the convex mirror and concave mirror. In our vehicles, we are using this convex mirror and concave mirror. Next, rules for ray diagrams and the sign convention. These all are topics today I am going to discuss with you. We'll see the introduction of light. Light is form of energy. It is the natural agent that stimulates sight and makes things visible. That means what we are going to see, what we are seeing, if we are able to see means that is due to the light. Optics. Here the two terms, what I told, ray and the optics. Optics, the branch of science which deals with the behavior of light is called optics. Here we are going to study about how light behaves. It has some properties like reflection, refraction, diffraction. All these properties can be explained in this optics. Next, ray. The path followed by the light is called ray. The light which chooses the path, the light chooses the path, that is called the ray. Here the ray is nothing but this is the ray. Next, the beam of light. The bundle of light rays is called beam of light. Bunch of light rays, that means here, these are called beam of light. These are called beam of light. Here the main things here we have to discuss about the optics and ray. So optics is, listen carefully students, the branch of science which deals with the behavior of light is called optics. ray. The path followed by the light is called as light. Here the bunch, the collection, the bunch of light rays is known as beam of light. Take a candle. Okay. See the flame through a straight pipe. Okay. See this candle flame through this pipe. You are able to see the light? Yes. You can able to see the light. Instead of the straight pipe, you just take the bended pipe. Okay. You just see the candle flame through this bended pipe. Is it visible? No, we can't see the light because here the bended pipe blocks the light. It travels only in the straight direction. So here the bended pipe blocks the pipe to travel in the straight direction. Understand? Here that means what we are proving now, the light always travels in the straight direction. Okay, next. Light doesn't require any medium to travel. It can travel through vacuum. There need not be any medium. Okay, it can travel in the free space, in vacuum also. Next, the speed of light. When we compare the other energy resources in the universe, the speed of light is having the greater velocity. The greater velocity. That is speed of light in vacuum, that is denoted with C, is equals to 3 into 10 to the power of 8 meter per second. And when we convert it in kilometer, that is 3 into 10 to the power of 5 kilometer per second. And there are some small properties of light. Light behaves. How the light behaves? Okay, the behavior of light in different ways. Different ways. Like a reflection, refraction, dispersion, diffraction, scattering, polarization. These all are the main important basic behavior of the light. In higher studies, we are going to learn very deeply about all these properties. These are all the characteristics of light. First one, foremost thing is light always travels in a straight line. That is rectilinear propagation of light. Next, it doesn't require any medium. It can also travels in the vacuum. Here, the speed of light is greater than all other energy resources in the universe. The speed of light is equals to 3 into 10 to the power of 8 meter per second. And light behaves reflection, refraction, dispersion, diffraction, polarization, scattering. These all are the characteristics of light. We'll see the different theories of light. These are the three theories explained by the different scientists. Okay. Here Newton particle theory and Huygens wave theory and Maxwell electromagnetic theory. First of all, Newton's particle theory. According to Newton, light consists of tiny particles. Light consists of tiny particles. They are known as corpuscles. They are known as corpuscles. So the light travels in the form of a tiny particle. The light spread in all directions in the form of tiny particles. And these particles are known as corpuscles. And this theory was also known as Newton's corpuscular theory. Here we are knowing about the different colors in light, like red, blue, green. Okay, I think everyone know. So the colors of light is due to the size of the particles. It depends upon the size of the particles. We are having the different colors. These are the assumptions of Newton particle theory. Okay. He fails to explain the terms diffraction, refraction and reflection. So according to Newton, the light consists of a tiny particles called corpuscles. To spread the light, all particles spread in all direction and they will give the light. This is according to the Newton's particular theory. Next, Huygens wave theory. According to Huygens, the light travels in the form of a wave. And we are knowing the different colors. The different colors of light is due to the difference between their wavelengths. Difference between their wavelengths. So he fails to explain the photoelectric effect and black body radiation. Next, Maxwell electromagnetic theory. According to Maxwell, the light wave consists of both electric field and the magnetic field. Okay, the electric field and the magnetic field, they are perpendicular to each other. They are perpendicular to each other in the propagation of light, in the direction of light. Okay, so according to Maxwell electromagnetic theory, light has a propagating wave of electric field and magnetic field. These electric field and the magnetic field both are perpendicular in the direction of light. So here observing the electric field and magnetic field, they are perpendicular. This is the Maxwell electromagnetic theory. What are the basic theories of light? Newton's particle theory, Huygens wave theory, Maxwell electromagnetic theory. So, Newton particle theory. Light consists of a small tiny particles. They are called as corpuscles. This theory is also known as Newton's corpuscular theory. And light consists of a different colors. The different colors are due to thus different size in the particles. Next, he fails to explain the diffraction, refraction and reflection. Next, Huygens, second theory was Huygens wave theory. So here a light will be in the form of a wave and the different colors of light due to different wavelength. He fails to explain the photoelectric effect, black body radiation. Maxwell electromagnetic theory. A light wave has both electric field and the magnetic field which are perpendicular in the direction to the propagation of light, And these are the three basic theories of light. Okay. For every scientist, the light looks like in different ways. For some scientists, it looks like particle. For some scientists, it looks like wave. These are the basic theories of light. Okay. Got student? Everyone understood? Reflection of light. Reflection of light, as I told, when we hit the ball, what happens? The ball just get back with the same speed at the same place. Similarly, reflection of light is nothing but when a light ray is incident on the surface, okay, then what happens? It just come back into the same medium with the same speed. That is nothing but the reflection of light. For this, take a plain mirror. When we incident a light ray, okay, the light ray which we are going to incident is known as a incident ray. The light ray, when you incident on a plane, what happens? It just reflected, okay, it just bounced back in the same medium, is known as the reflection of light. Here, incident ray, I have incident ray that is denoted with I. And what happened? The same light ray, incident ray, it just reflected. That light ray is known as R, denoted as R. Now, I have drawn a normal which is perpendicular to the plane. Here, what is meant by normal? Normal is nothing but a perpendicular line drawn on the plane. That is called normal. When I have drawn a normal, there will be angles. Here one angle, here another angle. So the angle between a incident ray and a normal ray is known as angle of incidence. Okay, and here the angle between the normal ray and the reflected ray is known as angle of reflection. This is angle I and this is angle R. Here main concept, that is law of reflection. There are two laws in this one. Here one, angle of incidence is equals to the angle of reflection. That means here suppose the angle is 90 degrees. The incident angle is 90 degrees. Then what may be the reflected angle? The reflected angle will also be 90 degrees. If the incident angle is 40 degrees and the reflected angle also will be 40 degrees. This is mean the angle of incidence is equals to angle of reflection. Here this is I, incident ray, and this is normal, and this is reflected ray. These three, okay, these three lines will lie on the same plane. Okay, these three lines are lies on the same plane. Okay, so here I is the incident ray, R is the reflected ray, and here angle I is angle of incident, the angle made between the incident ray and the normal, and here angle R, that is angle of reflection, the angle made by the normal and the reflected ray. Here these incident ray, normal and the reflected ray, the three lies on the same plane. These all two are the laws of reflection, and the angle of incidence is equal to angle of reflection is also known as the Snell's law. Okay, this is about the reflection of light. What is the reflection of light? The bouncing back of an incident ray, okay, with same speed in the same medium without any change of information. That is known as the reflection of light. We are, suppose we incident a light ray on the plane mirror. What happens? The light ray just reflected in the same medium. Here it is denoted with I, it is denoted with R. If we draw a normal in between these rays on the plane, okay, here they made two angles. This is angle of incidence and this is angle of reflection. Here the angle I is equals to angle R. That means whatever may be the angle of incidence, same that will be angle of reflection also. Both are equal. If it is 90 degrees, then that is also 90 degrees. If it is 30 degrees, that is also 30 degrees. Okay. Next. Here the three lines are placed on the same plane. Okay. That is incident ray, normal ray and the reflected ray. This is about the reflection of light. Spherical mirror are of two types. Concave mirror and convex mirror. This is concave mirror. This is concave mirror. Here it is convex mirror. Concave mirror, it is coated outside. Here this is reflecting surface. In convex mirror, it is coated inside and outer one is the reflected surface. What is concave mirror? A spherical mirror whose reflecting surface is curved inwards is called as concave mirror. Here it is coated surface. It is the reflecting surface. Convex mirror. A spherical mirror which is coated inside and the curved surface, reflecting surface is outwards is called as convex mirror. A spherical mirror is a part of a sphere. These are the convex and concave mirrors. What is, students? What is, how many types of spherical mirrors are there? Two types, concave, convex. The mirror which is curved inwards is called the reflecting surface, which is whose reflecting surface is curved inwards is called concave mirror, and the mirrors whose reflecting surface is curved outside is called convex mirror. Here a spherical mirror is a part of a sphere. These are the terms which we have to learn in the spherical mirrors. Pole, center of curvature, principal axis, principal focus, radius of curvature, object distance, image distance and focal point. What is pole? Pole, if we'll take a concave mirror, this is the concave mirror. It is coated outside. Okay, it is curved inside. If you take a concave mirror, here the center of mirror is known as the pole. It is represented by P. Okay, next. Center of curvature. If we extend this mirror, then assumed as a sphere, okay, the center formed C is known as the center of curvature. Okay, the center of sphere is nothing but the center of curvature. Next, principal axis. The line which is joining the pole and the center of curvature. Pole and the center of curvature is known as the principal axis. Okay, next. Principal focus. If we incident the parallel rays on the reflecting surface of a curved mirror, what happens? They just reflects at a point and they will meet at a point. Okay, they will reflect and they will meet at a point. This point is known as the principle of focus. What is principle of focus? If we incident the parallel beam of light to the reflecting surfaces, the rays reflected and the rays will meet at a point. The point is known as the principal focus. Next. It is represented with the capital F. Next one, focal length. Focal length is the distance between the P and F. Distance between the pole and the principal focus. It is represented with the small f. That is focal length. Radius of curvature. Radius of curvature is the distance between the pole and the center of curvature. What is mean by radius of curvature? The distance between the pole and the center of curvature. It is represented with the capital letter R. Okay. Next, object distance. If I will take a object. Its name is OJ. What is its name? Its name is OJ. Here, the mirror image will form here. Okay. Here, this is OJ. The distance between the pole and the object, that is represented with U. The distance between the pole and the object is known as the object distance. Okay, next, image distance. Here image. Here we have seen the image that is represented with I. Here the distance between the image and pole and the image. The distance between the pole and the image is known as the image distance. Okay, this is represented with small v. These all are the terms. Pole. What is pole? The pole is the center of the mirror. First one. Next, what is center of curvature? Here, when we extended the concave mirror, we will get a sphere. The center formed is known as C, center of curvature. Next, principal axis. The line joining the P and C is known as principal axis. Pole and the center of curvature. Principal focus. If we focus the parallel lights, they will reflect it and they will meet at a point. The point is known as principal focus, that is represented with F. Next, focal length. Here the distance between the principal focus and the the distance between the pole and the principal focus is known as the focal length. Next, radius of curvature. The distance between the pole and the center of curvature is called radius of curvature. Dear students, here near radius of curvature, we have to know one thing. Here, we are having two F's. That is, 2F is equals to R by 2. Okay. Sorry. Here students, we have to note one thing. Here near radius of curvature, we are having two F's. That is, F is equals to 2R. Then R is equals to F by 2. Okay, here near radius of curvature, we have to note one thing. What is the relation between 2F and R? So, 2F is equals to R. Okay, F is equals to R by 2. If F is 20, then R is equal, if F is 20, then R is equals to 40. For it is double. Okay. So this is the relation between 2F is equals to R. Next, object distance. What is object distance? The distance between the object and the pole. Next, what is image distance? The distance between the image and the pole. These all are the main important terms in the spherical mirror. When you will know all these terms, then only you can easily draw the ray diagrams. Okay, fine. Understood, students? Another ninth term, it is magnification. What is meant by magnification? Magnification is denoted with M. Magnification is equals to height of the image by height of the object. That is ratio of the height of the image and height of the object. Height, sometimes height is not but size of the image by size of the object. It is ratio, so due to the ratio, it is not having the units. Rules for the ray diagrams. There are 4 rules for the concave mirror and the convex mirror. So, rule 1. When a parallel light is incident on the reflecting surface, okay, the light just reflects by passing through the principal focal point. This one is the first rule. And when we come to the convex mirror, here when the light ray is incident parallelly to the principal axis and it incident on the reflecting surface, what happened? The light just diverges. The light just diverges, and it is look like the light is coming from the focus point. That is focal point. That is principal focal point. Okay. So what is first rule? When the light is parallel to the principal axis, it just hits the reflecting surface and reflected by passing through the principal focal point. Here, what happens when the light ray parallel to the principal axis falls on the reflecting surface, the light just diverges and it looks like the light is coming from the principal focus point. Next, rule 2. Here, when the light is incident and passing through the principal focus point, it just reflects along with the principal axis. Okay, when the light passes through the principal focus point, what happens? It just reflects, touches the reflecting surface and passes like that along the principal axis. Here, when we consider the convex mirror, when the incident light ray falls on the reflecting surface, what happens? Here also it just reflects like along with the principal axis. Here we'll see the light is coming from the focus point. Okay. Here, next, third rule. What is third rule? When the light passes through the center of curvature, it just touches the reflecting surfaces. It come in the same way. Okay, it passes along on the center of curvature. Okay, if the light come in this direction also, it just come like this and hit the reflecting surface and it just goes back. Next, here also, when the light comes along the direction of center of curvature and it again reflects back in the same direction. Here also it's looking like the light is coming, reflecting ray is coming from the center of curvature. Next, rule 4. Here the reflecting the incident ray touches the reflecting surface obliquely and it reflects obliquely. Okay, here the angle of incidence is equals to angle of reflection. Here also, when the incident ray touches the reflecting surface, when it touches the pole, okay, when it touches the pole, what happens? It just reflects back. Okay, here also capital I is equals to capital R. These are the four rules in the rules of ray diagrams. Okay, if we got the concept that the light, the incident ray passes from the focus point, means we just remind that just it will passes through the along with the principal axis, parallel to the principal axis. Okay, understood students? 4 ray diagrams. We'll see for the sign convections for the convex mirror and the concave mirror. So let's see for the concave mirror. This is the rough surface, this is the reflecting surface, pole, center of curvature and focus point. Okay, first, all the distance should be measured from pole. I am measuring for focal length. Here it is the incident ray. This is the object OG. If I will incident a ray, okay, how I will take the focal length F is equals to from P to F. In which direction? In this direction, forward. So it is opposite to the incident ray. So it is negative. Distance measured in the direction of opposite. These two completed. Got it? So if we will take the opposite, then it is negative. Next, or radius of curvature. It is the distance between the P and C. pole and the center of curvature. Pole and the center of curvature are. The measurement can be taken opposite to the incident ray. That is okay. The incident ray, okay, towards the reflecting surface, and the measurement we are taking away the reflecting surface. The both are opposite, then negative. Next, object distance. What is object distance? The distance from the pole and the object. So we are taking the measurement along with the opposite to the incident ray. That is negative. Next, image distance. Here in image distance there will be positive and there will be negative depending on the case. Here if I place the object here, the image will form here. Okay. So how I am taking the image distance from P to I? It is opposite to the incident ray. It is negative. If I will place the image here, okay, what happens? The image object here, the image will form beyond the reflecting surface of the mirror. So how I have to take? I have to take in this direction. So here both are equal. The incident ray and the measurement of the image, okay, are same. Then it is positive. Got it? So here the heights measured above the principal axis as positive. This is the principal, above the principal axis, and below the principal axis is nothing but the negative. Okay. Next, convex mirror. Pole, center of curvature, focus point. Okay. So we have to find the focal length. If this is the incident ray. Here focal length we have to measure. So all the distances should be measured from the pole only. From pole I am measuring the distances in this way. So it is equal to the incident ray. That is, both are same. They are in the same direction. So F is equals to positive. Next, R. R is the distance measured from C to P. That is P to C. That is pole to center of curvature. So R is equals to, in this direction I am measuring, and the incident ray also in this direction. They are in the same direction. It is positive. Next, object. Here I am placing a object here, O, G. The distance from P to O, okay, the distance from the pole to object is the object distance. So it is in the opposite direction. So we got negative. Next, image distance. If object is here, the image will form inside the mirror. So it is, the measurement should be taken along with the incident ray direction. So they are in the same direction. So it is positive. Okay, these all are the five cases we have to remember. First, all the distances should be measured from the pole only. Distances measured in the direction of incident rays are taken positive. Distance measured in a direction opposite to the direction of incident ray is taken as negative. Next, the heights measured above the principal axis as positive. Below the principal axis taken as negative. When we all remind these points, then we can understand the convex and concave mirrors. And in problems also we are going to use all these signs to perform the and solve the problems. Understood everyone? Thank you.